नमस्कार, मैं राकेश कुमार स्वागत करता हूं आपका टैगोर साइंस स्कूल तारानगर के द्वारा संचालित डिजिटल ऑनलाइन क्लासेस के इस प्लेटफॉर्म के ऊपर। आज अपन 10th क्लास इंग्लिश मीडियम ऑप्टिक्स का जो चैप्टर अपन स्टडी कर रहे थे उसमें अपन नेक्स्ट पार्ट अभी कंटिन्यू करेंगे। प्रीवियस वीडियोस के अंदर अपन ने लाइट के जनरल कैरेक्टरिस्टिक्स, रिफ्लेक्शन, लॉज ऑफ रिफ्लेक्शन एंड उसके अलावा जो अपन ने रिफ्लेक्शन से रिलेटेड कुछ आपकी बेसिक टर्म्स जो थी, इंसिडेंट रे, रिफ्लेक्टेड रे, नॉर्मल, रिफ्लेक्टिंग सरफेस, एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्लेक्शन एंड अपार्ट फ्रॉम दैट अपन ने दो लॉज पढ़े थे जो आपके रिफ्लेक्शन से रिलेटेड हैं। और वो दो लॉज जो थे उसमें से फर्स्ट लॉ अपन दोबारा एक बार रिवाइज कर लेते हैं। फर्स्ट लॉ वाज दैट एंगल ऑफ इंसिडेंस इज इक्वल टू एंगल ऑफ रिफ्लेक्शन. This was the first law of reflection, that angle of incidence. And what is angle of incidence? The angle between normal and incident ray. The angle between normal and incident ray is angle of incidence. And what is angle of reflection? The angle between normal and reflected ray is called angle of reflection. So first law states that angle of incidence is equal to angle of reflection, and second law is incident ray, reflected ray and normal. These three, incident ray, reflected ray and normal, all lie in the same plane, or in other words we can say that incident ray, reflected ray and normal all are coplanar or exist in the same plane. So that was the quick revision of laws of reflection that we have studied in the previous video. Now in this video we will study about the types of mirrors. So first of all, what is mirror? So mirror is a reflecting surface which has the capacity to reflect the light in maximum amount. So mirror is a smooth and shiny surface which provides maximum reflection of light. That smooth and shiny surface which has the capacity for the maximum reflection of the incident light is called mirror. So in this video we will study about the types of mirrors, the categories in which the mirrors can be classified. Okay, so what is mirror? Mirror is a smooth and shiny surface which has the capacity to reflect the maximum amount of light that is incident upon it. Okay, so to construct a mirror, let's assume that we will take a surface of glass which can be either curved or plane. So this surface of glass that is curved or plane, this side of the surface is polished with silver to make it shiny and smooth. So this is shiny and smooth surface which executes the work of reflection, and the other side or the opposite side of the reflecting surface is painted to stop the transmission of light. Now the back side of the mirror, which is in the opposite direction of reflecting surface, is painted to block the light or to block the transmission of light. So in mirror, whether it can be spherical, plane mirror, which means the mirror can have a spherical or a curved surface, or it can have a plane or a flat reflecting surface, but the first side or the one side of the surface is polished so smooth that it provides the maximum reflection to the incident radiation or the incident visible light. The opposite side of reflecting surface is painted to block the transmission of light. Okay, so mirror is what? Mirror is a smooth and shiny surface which provides the maximum reflection to the incident visible light. Now there are two categories of mirrors. First one is plane mirror and second one is spherical mirror. There are two types of mirror. First one is plane mirror, second one is spherical mirror. So first of all, what is plane mirror? you can understand from the words plane and spherical. Plane means the mirror which has a flat reflecting surface. The mirror which has the flat or plane reflecting surface is called plane mirror, and while the spherical mirror, as its name implies, that spherical mirror has the reflecting surface in curved shape. So plane mirror has the flat reflecting surface, while the spherical mirror has curved reflecting surface. Okay, so there are two categories of mirrors. First one is plane mirror, second one is spherical mirror. Plane mirror consists of flat reflecting surface and the spherical mirror consists of curved reflecting surface. Now let's move on to the first category, which is plane mirror. The plane mirror has a flat reflecting surface. Now this is the reflecting surface which is made smooth and shiny and just perfect for the maximum amount of reflection that it will provide to the incident visible light or the incident radiation. So this is the reflecting surface. Now the opposite side of mirror is painted to block the transmission of light. So the painting on the other side or on the opposite side of reflecting surface is represented by these lines. So this is the painted surface of mirror which blocks the light from transmitting through the mirror. So this is the painted surface. So the definition of plane mirror is what? The mirror which has a flat or plane reflecting surface is called plane mirror. Okay, so the plane mirror has the flat reflecting surface. The reflecting surface is made smooth and shiny, and the opposite side of the reflecting surface is painted to block the transmission of light. Next one, the characteristics of image formed by the plane mirror. Now if you put an object before the plane mirror, then the plane mirror will form the image. Now we have to study what will be the nature or the characteristic or the parameters of the image that will be formed by the plane mirror. So now the image formed by the plane mirror is virtual and erect. So this is the nature of image that is formed by the plane mirror. What is the nature of image formed by the plane mirror? The nature of the image which is formed by the plane mirror is virtual and erect. This virtual and real image, that is the classification of image in two categories. One is virtual and other one is real image, that we will study in the upcoming videos. For this time you have to remember that the plane mirror constructs a virtual and erect image of the object which is placed before the mirror. Next one is size. The size of image is same as of the object. So the nature of image is virtual and erect, and the size of image is same as of the object. And one another thing, if you want to get the full image of an object whose height is small h, then the minimum height of the plane mirror must be greater than or equal to the half height of the object. So if there is a question of 1 mark that what should be the minimum height of a plane mirror to get a full image of an object of height h, then the answer would be the minimum height of plane mirror which is required to get or to see the full image of an object of height h is h upon 2, which means the minimum height of plane mirror must be the half of the height of object to get a full image of that particular object that we are looking at. Okay, so in plane mirror, first one is the definition of plane mirror. What is plane mirror? Plane mirror is a type of mirror which has a flat reflecting surface or a plane reflecting surface is called plane mirror. Second question is, mention the nature of image formed by the plane mirror, and the answer would be the nature of image formed by the plane mirror is virtual and erect, Now the third question, what would be the size of the image formed by the plane mirror? And the size of image formed by the plane mirror would be same as of the object. Next question is, what should be or what must be the minimum height of the plane mirror to get the full image of an object of height h? And the answer would be, the minimum height of plane mirror must be the half of the height of plane mirror to get a full image of an object of height small h. So these are all the facts, information, question and answer related to plane mirror. That is the first category of mirror that we are studying today. Now let's move on to the second category, which is spherical mirror. Now what is spherical mirror? In plane mirror, we have studied that the plane mirror has the reflecting surface as plane or flat, while the spherical mirror, these mirrors have curved reflecting surface. What is the shape of reflecting surface in spherical mirror? The shape of reflecting surface in spherical mirror is curved, which can be either in inward direction or in outward direction. That depends upon the type of spherical mirror that we are talking about. But on a general point, it can be said that the spherical mirror has the reflecting surface shape as curved reflecting surface. Okay, that is the definition of spherical mirror. So the mirror which has a curved reflecting surface is called spherical mirror. Okay, now the question is, why these curved shaped mirrors are called spherical mirror? What is the reason behind the nomenclature of these mirrors as spherical mirror? The reason is, these mirrors are carved out from a hollow sphere. The mirrors or the spherical mirrors that we are studying in this video or in the next slide are made or are carved out from the hollow sphere. That's from where the name comes, spherical mirror. So that's why they are called spherical mirrors. So the reason behind the nomenclature of these curved shaped mirrors as spherical mirrors is that these mirrors are carved out or manufactured out by the hollow spheres. That's why these mirrors are called spherical mirrors. Now there are two types of spherical mirrors. Okay, first one is concave, next one is convex. So there are two categories of spherical mirrors. First one is concave mirror, second one is convex mirror. So first is the definition of spherical mirror. What is the definition of spherical mirror? The spherical mirrors are those types of mirror which has the reflecting surface in curved shape, or the mirror which has a curved reflecting surface is called spherical mirrors. These mirrors are carved out from a hollow sphere. These mirrors are made out of a hollow sphere. That's why these mirrors are called spherical mirrors. And there are two categories in which these spherical mirrors can be classified. First category is concave mirror and other category is convex mirror. Okay, so these two categories belongs to spherical mirror. Now we will study about these two categories one by one, concave mirror and convex mirror. First one is concave mirror. The diagram that you are seeing here belongs to concave mirror. In this black surface is reflecting surface and this grey surface is the painted surface. And you very well know about the purpose of reflecting surface and the painted surface. What is their purpose? The reflecting surface executes the work of reflection of the incident radiation, while the painted surface blocks the transmission of light through the mirror. So if you look closely at this image or at this figure, you will see that the reflecting surface of concave mirror is depressed in inward direction. Okay, the reflecting surface of concave mirror is depressed inward. If we look from the side or from the left side, then it seems that the reflecting surface of concave mirror is depressed inward. So the spherical mirror, which has the reflecting surface depressed inward or in inward direction is called concave mirror. That is the definition of concave mirror. The reflecting surface of concave mirror is curved inward or depressed inward. So, and why we are looking from the left side at the mirror? Because by convention, remember this fact, the object is always placed on the left side of the mirror. That is the convention of optics. Okay, so by conventional law, the object is always placed on the left side of the mirror. That's why we are looking at the mirror from the left side. Okay, so now when you look from the left side at the mirror, and if you find that the reflecting surface is curved inward or depressed in inward direction, then that mirror will be what? Concave mirror. Okay, so this is the first category of spherical mirror, that is concave mirror. So what will be the definition of concave mirror? The reflecting surface of concave mirror is curved inward, or the spherical mirror which has the reflecting surface depressed inward is called concave mirror. And what is the standard direction in which we put the object? That is, the direction is left direction. Object is always placed on the left side of the mirror or any optical instrument, not specifically mirror, it can be lens, microscope, telescope, any optical instrument. Second category is convex mirror. This is the diagram of convex mirror. In this diagram, as we have seen in the previous mirror, that is concave mirror, that this is the reflecting surface and this grey surface is the painted surface. I will not revise the purpose of reflecting surface and the painted surface, but when we look from the left side, then we can see that the reflecting surface is bulging outward. Okay, unlike the concave mirror, when the reflecting surface is depressed in inward direction, in convex mirror, when we look from the left, then the reflecting surface seems to be bulging in outward direction. So if the reflecting surface is bulging in outward direction, then the mirror is called convex mirror. That is the definition of convex mirror. What is the definition of convex mirror? The mirror in which the reflecting surface is bulging outward, then the mirror is called convex mirror. Okay, that is the prime difference between convex and concave mirror. And what is that difference? In concave mirror, the reflecting surface is depressed inward, and in convex mirror, the reflecting surface is bulging in outward direction. That is the prime difference between convex and concave mirror. Although both these mirrors belong to the same category of spherical mirrors. Okay, so these are the two categories of spherical mirrors. First one is concave and second one is convex. Okay, so there are two major categories of mirror, plane mirror and spherical mirror, and there are two subcategories of spherical mirrors, concave mirror and convex mirror. Okay, now the next point is the definitions related to the spherical mirrors. There are some certain parameters which are related to spherical mirrors. In this diagram, all these parameters are mentioned. The mirror that we have considered here is, as you can see, is concave mirror, because if we look from the left, then the reflecting surface is depressed in inward direction. So this mirror is what? Concave mirror. Here light comes from this side, which means light comes from the left side, and the reason behind this fact is that object is always placed on the left side. Now this is the reflecting surface, this is a painted surface or hard surface which blocks the transmission of incident radiation. Now we will cover the parameters related to spherical mirrors one by one. So first parameter, and the first parameter that we are going to talk here is capital P, pole. And what is pole? Pole is the center of the reflecting surface of spherical mirror. The center or the midpoint of this reflecting surface of spherical mirror is called pole, and it is represented by P. So this is concave mirror, this is convex mirror. What will be the center of reflecting surface here? So the center or the midpoint of the reflecting surface is called pole. That is the definition of pole. So what is the definition of pole? The center or the midpoint of the reflecting surface of a spherical mirror is called pole. Okay, let's move on to the second definition, and the second definition is center of curvature, which is denoted by capital C. From the previous point we can mark pole, which is the center of the reflecting surface of the mirror. Now what is the center of curvature? We have studied in spherical mirrors that spherical mirrors are carved out from the hollow spheres. That's why they are called spherical mirrors. Okay. So this concave or convex mirror was at a time a part of a hollow sphere. That hollow sphere was eliminated and this part is cut out from that sphere, and we have formed the concave and convex mirror. But let's not forget that once upon a time these two types of mirrors were a part of hollow sphere, and the center of that hollow sphere is called center of curvature. So the definition of center of curvature would be the center of the sphere from which the mirror is carved out is called center of curvature. Okay, so if we look at the alignment of the surface of this concave mirror, then it would seem very easy to guess in which direction the center of this surface would be. The center of this sphere would be in the left side. Okay, and in convex mirror the center of the imaginary sphere would be on the right side. So what is the center of curvature? The center of curvature is the center of the sphere from which the mirror is carved out is called center of curvature, capital C. Okay. Now the next definition that we are going to study is radius of curvature. Okay, what? Radius of curvature. And that radius of curvature is the separation between pole and center of curvature. The distance between pole and center of curvature is called radius of curvature, and it is denoted by capital R. So this is the definition of center, radius of curvature. The distance between pole and the center of curvature is called radius of curvature. It is represented by capital R. Here is the definition of radius of curvature. The distance between pole and the center of curvature is called radius of curvature. This is the pole. This is the center of curvature. This is pole, this is the center of curvature, and the distance between pole and center of curvature is radius of curvature. Okay. So what is radius of curvature? The distance between pole and the center of curvature is called radius of curvature. Okay. Let's move on to the next definition, which is focus. Okay. But before focus, let's find out what the principal axis is. Okay. The principal axis is an imaginary line. It is not present in real. It is an imaginary line which we have constructed to understand the phenomena of reflection from spherical surfaces. And what is this imaginary line? The imaginary line which joins the center of curvature and pole. The imaginary line joining the center of curvature and pole is called principal axis. So the imaginary line which passes through the pole and the center of curvature is called principal axis. This is the definition of principal axis. Okay, what is the definition again? The imaginary line joining the center of curvature and pole is called principal axis. Okay, let's move on to the next definition, which is focus. So first, the center of the reflecting surface is pole. So we will mark the pole. Okay. Next is what? The center of the sphere from which mirror is carved out is called center of curvature, capital C. The line which is joining the pole and the center of curvature is principal axis. Okay. Now, what is the focus, which is represented by capital F? What is this focus? Consider that light rays are coming parallel to the principal axis. The incoming or the incident light rays are coming parallel to the principal axis, and this strikes the concave mirror at this point. What is the function of mirror? Mirror reflects the incident radiation. So, this concave mirror will reflect the incident or the incoming radiation that is coming parallel to the principal axis, and these reflected light rays will pass in this direction, and these reflected light rays would intersect the principal axis at this point, and this point of intersection upon principal axis is called focus. Okay. So these are the incoming light rays which are coming parallel to the principal axis. Upon incidence on concave mirror, these light rays will be reflected, and these are the reflected light rays, and these reflected light rays will intersect the principal axis at this point, and the point of intersection is called focus. Okay. Now for the convex mirror, again these are the incoming light rays which are coming parallel to the principal axis. The mirror would reflect the incoming light rays, so these are the reflected light rays. Okay. Now in this direction there is no possibility that these reflected light rays would ever intersect the principal axis, because they are going away from the principal axis. There is no chance that these light rays would in any case intersect the principal axis. In that particular case, when there is no possibility of intersection, then we will trace in backward direction, or we will trace the imaginary path that would seem. Okay. Now if we look from here, then what would you see? If you look from here, then you would see that these light rays are coming from this particular path, and this imaginary path is cutting or intersecting the principal axis at this point. This intersection is quite imaginary, this is not real. Okay. These lines or these reflected light rays seems to be coming through this point, and this virtual or this imaginary point of intersection upon principal axis is called focus. So what would be the definition of focus? The point at principal axis. Okay, focus is situated at principal axis from which the light rays, and which light rays? The light rays which are coming parallel to the principal axis. This is the condition. The light rays or the incident light rays must be parallel to the principal axis. In this case, these incident light rays are parallel to the principal axis, and this is the same in this case, pass through or seems to be passing through. Pass through in real sense. These reflected light rays are passing in reality through the focus, while these light rays seems to be passing through this virtual point of intersection. So this definition includes both these possibilities. The first one is when the reflected light rays are passing through the focus in real sense, and in this case the reflected light rays seems to be passing through this virtual point of intersection. So what is the definition of focus? The point at principal axis from which the light rays coming parallel to the principal axis pass through or seems to be passing through is called focus, which is denoted by capital F. Okay. So capital F is the point on principal axis from which the light rays would pass after reflecting from the mirror. In concave mirror, the light rays would pass in real from the focus, and in convex mirror the light rays would pass in virtual or in imaginary manner through the focus. That is the definition of focus. Now let's move on to the next definition, which is focal length. Okay, we have to study about the focal length. The focal length is denoted by small f. So first, this is the principal axis. We will mark pole. Now we will mark center of curvature and focus. Okay, and what is focal length? The distance between pole and focus. The distance between pole and focus is called focal length. So this distance or this separation between the pole and focus is called focal length. So we can say that the separation between pole and focus is called focal length. As you can see that focal length is on the left side, focus is on the left side for concave mirror, but in convex mirror focus and focal length both are on the right side. And why we are talking about the sides in which the focus and the focal length is placed? Because when we are going to assign the positive and negative sign to the focal length, to the radius of curvature and the object distance and image distance, then we would require the knowledge of direction in which the focus, focal length, radius of curvature, center of curvature is placed. So for concave mirror, the center of curvature, the focus, the focal length, the radius of curvature is in the left side. But in convex mirror, the focus, the center of curvature, the focal length, the radius of curvature all exist on the right side. So what is the definition of focal length? The separation between pole and focus is called focal length, which is denoted by small f. Now let's move on to the last definition, aperture, which is the diameter or the length of the reflecting surface of mirror is called aperture. This is the last definition of mirrors or related to the spherical mirrors, that the diameter or the length of the reflecting surface of mirror is called aperture. So these were all the parameters related to the spherical mirrors, from pole, which is the center of the reflecting surface of the mirror. Second one is what? Center of curvature. The center of the sphere from which the mirror is carved out is called center of curvature, capital C. The distance between pole and center of curvature is radius of curvature, capital R. The line joining the pole and the center of curvature is called principal axis, and the point at principal axis from which the incoming light rays, which are parallel to the principal axis, would pass or seems to be passing through, is called focus, and the distance between pole and focus is called focal length, and the length or the diameter of the reflecting surface of the mirror is called aperture. These were all the parameters that were related to the spherical mirrors. Okay, in next video we will study about the types of images. One is real image and one is virtual image. We will also study about the sign convention. Okay, and third topic that we will study in the next video tomorrow is the relation between radius of curvature capital R and focal length small f. That is the relation between radius of curvature and focal length. What would be the relation that we are going to find in the next video. Till then, stay home, stay safe, goodbye.